Download this code from codegive.com, link in the description below. Creating a visual representation of Lean 4 proofs using Blender's tactics keyframes can be a fascinating project that combines formal verification with 3D animations. Below is a tutorial that outlines the basic steps to visualize Lean 4 proofs using Blender and tactics keyframes. Prerequisites. 1. Lean 4. Ensure you have Lean 4 installed on your system. 2. Blender. Download and install Blender, preferably the latest version. 3. Basic knowledge of Lean 4, familiarity with Lean 4 syntax and tactics. 4. Python scripting, basic understanding of Python, as we'll be using it to automate parts of the process. Step 1. Set up your Lean 4 environment. Before visualizing proofs, you need to create a Lean 4 proof that you want to visualize. Here's a simple example. Lean. Import the necessary libraries. Import mathlib.data.nat.basic. A simple proof of the theorem, for any natural number n plus 0 equals n. Theorem @_0, n plus 0 equals n equals. nat @_0 n. You can build upon this proof to create a more complex one as needed. Step 2. Generate proof data. To visualize the proof, you'll need to extract the proof structure and the tactics you used. Lean 4 allows you to trace the tactics used in a proof. You can use Lean's logging capabilities or write custom functions to output the proof steps in a format suitable for Blender. Here's an example of how you might log the steps. Lean. A helper function to log steps. Def log tactic, string, io unit equals do. io.println s. Executing tactic. You can call this function within your proof to log each step. Step 3. Export data for Blender. Once you have the proof data, you need to export it in a format that Blender can understand. A common format is JSON. Here's how you might serialize the proof steps. Lean. Import lean.data.json. Def export proof steps, list string, io unit equals do. Let JSON equals json.mk array, steps.map json.mk string. Let file path equals proof_steps.json. io.fs.write file path, json.pretty.json. Call this function after logging each tactic to create a JSON file containing the proof steps. Step 4. Load data in Blender. Next, you need to load the proof data into Blender. You can use Python scripting in Blender to read the JSON file and create keyframes based on the proof steps. 1. Open Blender and navigate to the scripting workspace. 2. Create a new script and enter the following code. Python. Import JSON. Import bpy. Load the JSON file. With open, path/to/proof_steps.json, r, as f. Proof_steps equals json.load, f. Assume we have an object to animate. Obj equals bpy.context.active_object. Create keyframes based on the proof steps. For I, step in enumerate, proof_steps. Frame_number equals I*10. Adjust the frame spacing as needed. Object keyframe_insert, data_path equals location, frame equals frame_number. You can customize the location or rotation based on the step. Object location.z plus equals 1 example of moving up for each step. Make sure to replace path/to/proof_steps.json with the actual path to your JSON file. Step 5. Visualize the animation. 1. Run the script in Blender. 2. Press the play button to see the animation of the proof steps. Step 6. Enhance the visualization. You can enhance the visualization by customizing the object's properties, color, shape, etc., based on the proof's progress. You could also add text annotations to explain what each step represents. Conclusion. This tutorial provides a basic framework for visualizing Lean 4 proofs in Blender using tactics keyframes. You can expand upon this by creating more complex proofs, refining the data export/import process, and enhancing the 3D visualization in Blender. This project showcases the intersection of formal verification and 3D modeling, making abstract concepts more accessible and engaging.